Hello, this is a bit of an impromptu stream and I thought I would do a bit of a repair stream live whilst I'm looking at some VTXs. Now I'm assuming we're up and running. It says there's one person watching. It's going to catch a few people out this one because people won't be used to me going live randomly on the channel, but we're going to do it anyway. So what we're going to be doing is taking a look at some VTXs and just having a look at what the issues we're seeing on one or two of these is and doing some diagnostics along the way and try and have a look if there is what's been said wrong with them, and also explain a few things as I do it. Now I've been sent I think 6 VTXs here. I've got 3 here in one pile. 2 I've already repaired actually, and we'll talk about them. Got another 2 here, and there is currently one, if I find the button, no, that one there. There is currently one there on the bench as well. Now, I'm going to try and keep this interactive, guys. I do have a second camera over here whilst I'm using the microscope, and you can see what I'm doing as I'm looking through as well. And actually, let's just try and tilt that probably down a bit more. You'll get to see probably a bit more of what I'm doing that way. Probably need this one higher, to be honest. It could do with being a bit higher so you can see more of what I'm doing, but we might figure that out as we go along. But as always, we'll try and see what it does. Now, as always with these things, it's understanding what the issues are, and I'll jump into it a little bit at the moment. I've had a lot of people reach out. In fact, there's someone there who's reached out to me. Please send me a message on my Discord. I've had a lot of people reach out to me about getting VTXs repaired. And look, I'll try and do some stuff as I can. The problem I've got is I can't do this full time. I'll never get the channel done, if you know what I mean. But this one was an interesting batch because there was 6, I think, here sent over to me with all different problems, and we've been able to repair a few. Interestingly, found a new problem on the HDZero Whoop VTXs, and these are all Whoops. All of these boards are Whoops. The originals, not the new Whoop Lite. And I found an interesting fault I've not seen before, and I'll show you that on one of the boards as well. Now, good evening, everyone who's watching. If you are new here, welcome. We'll hop over to the bench, and we'll zoom out a little bit, and I'll show you this one. Let me just get myself set up properly, get the microscope focused. I need to actually align the focus in on the camera as well. There you go. Now this is a Whoop VTX, this one, and this one, oh, it's still a bit blurry, that's a bit better. This one has lost the UFL connector and it's caused a little bit of damage, but the report with this VTX as well is that it's not working either. Now we do have another one of these that had damage, a broken UFL. Let me just find it so I can show you the repair I've done on it. It's this one here, if I am right. Is it that one? Yes, it is. There is one I've already done a repair on, and I thought I'll just show you guys this. And I've done a test on this, and this one's already done. This will probably be part of the video. This one had a broken UFL, but it also had ripped the track up quite substantially. So the track on this one had been ripped up all the way to there. So what we've now done is put a small piece of wiring. We've got the cap back, and we've got a new UFL connector on as well. Whilst it might not be perfect from an RF point of view, it should be fine. It should work absolutely fine. I haven't got an image of how this one actually looked before we did the work, but that just gives you an idea of the kind of thing that we will be doing. So the first thing we need to do on this one, this damaged one, is put a UFL on it and test it. Now I could cheat actually, and I am going to cheat. And that is, before we mount a UFL, we really want to understand if this VTX works. And we'll put a bit of wire on to act as an antenna. That way it's not going to burn out. We're not going to cause any trouble doing that. I've done that a few times in the past. What we'll do first though is just clean up around this area with the iron, just to try and remove any residue. Just make sure that there's nothing left. We can see that that's gone. Don't want to get too close to him. There we go. That all looks fine. So that's nice and tidy. We'll then get a cotton wool bud and just give that a bit of a clean up with isopropyl. I've got that here. Just so before we get into it in a minute, we'll know we'll be okay. Now, just to test this, what I'm going to do is create a small piece of antenna. For this, we'll use a bit of wire. I'm not gonna cut it exactly the right wavelength. You can do stuff like that and get the wavelength right. I'm not interested in that. All I want to do is make sure the power amplifier doesn't burn out is the basics. Otherwise, I'll have to replace it with a power amplifier we've got here. So all I'm going to do on this is just tag on to that capacitor there a little bit of wire. Just as a very quick and temporary solution. Here we go. Just something. So there's a wire attached, just basically just to act as an antenna. Because we just want there to be something so when the power amp kicks in, it's got something to throw that RF against. Yes, it's not perfect, but we're not going to burn the antenna out on one little occasion. So what we're going to do is put 2 power supply wires onto this one. I've got my power supply hooked up behind me there. For some reason, my wires are fighting me, stopping me getting it under the camera. 1 second. Okay, good. Somehow I've managed to get the soldering iron right through the middle of my power supply cables. I don't know how I managed to do that. Okay, so I'm just going to get that all fine. And the first thing we're going to do is we're not going to put a camera on. I just want to see the current draw on the power supply. So I've got a bench power supply here, giving you guys an idea. There it is there. You can see on the top. And we're just going to have a look at what sort of current this draws and whether the LED kicks in when we fire it up as well. If I turn that light off, you can now see the board there as well. It's darkened the microscope. So what we'll do is fire it up first of all. So we've got power. That's a good sign. And the power supply is drawing, it was 0.7 of an amp and now it's down to 0.18. I'm quite happy with that. That's telling me that things look reasonable at this point. So what we will do is we're going to plug the camera on as well. I have a camera on the bench here for testing. And then what we're going to do then is see what LEDs we get flash on the whoop. Because what we're looking for is that LED, the red one to kick in. So I'm going to fire up and then get a sort of a random flash on the blue, ideally, if we're getting communication across the camera. I should have probably had a blue by now. Oh, there it is. Okay, that's a good sign. That's quite a good sign. Let me just check it for temperature. Things are getting warm. Let's turn a set of goggles on and see what happens. We may have video. I have cleaned this board as well, so I just want to make sure it's functional in some form before we mess around and put a UFL on it. Just wait for the goggles to boot. Oh, I got signal. I got something. It's not perfect because there's no thing. Get down there. It doesn't want to lock on, but that doesn't mean it's... I'm just trying to scroll through the channels just to see. Do we get anything from him? Ooh, it's interesting. We're getting an image, but it's not working properly. But there is something there. Okay. It's a little bit interesting. Now I have ran one of these on a wire before and actually had it work. But okay, the fact, and we'll power that down, the fact I'm getting some form of an image is making me want to go and put a UFL on it. So what we'll do is we'll get a board with a spare UFL on. I've got a couple of spares here. Let me just find the right one. Here we go. This one here. We're going to use this board. This is a clean board. I'm going to be very careful on this one to remove the UFL because this board actually has another problem. But I'm going to borrow the UFL off this one, and then we'll do that hot air, and then we'll use this as our donor for putting a UFL and a repair on that one, and then we'll have a look at how it performs then. So what we're just going to do is get some heat on it, not too much, too quickly. I can see there's a couple of questions. I'll come over and answer them now in a minute, guys. Give me a moment. There we go. Sorted. Just coming over to the questions. Was that no clean flux you used earlier? What did I use earlier? The flux I've just used now is rosin core. This is traditional flux. I've been using this rosin flux paste. I've been using this quite a lot recently rather than the more expensive traditional tube flux. If you use a lot of it, the tube fluxes get really expensive really quickly. Let's get that wire off that as we put that on as a demo. Yeah, the tube flux gets really expensive quickly when you're messing around on the bench. So I tend to use this rosin, this just tubs of this thicker. It's much thicker. It doesn't flow like the other stuff. Now what I'm going to do next is I'm going to put a bunch of solder on there. Sorry, the power supply cable is dragging us off. Behave, please. Where are you? Sorry, the power supply cable's got a bit of tension on it. There we go. I'm just going to put some lead solder on here first of all. So I'm just going to put plenty on, and then we'll clear all of this up in a minute. Just plenty of solder. I want to get rid of that horrible lead-free stuff that has been on the connector already, because that's just the bane of everyone's life. It's just not good stuff. So what it's not doing now is wicking that off. Come on. Oh, we're close. Put a bit too much on there. I can get some wick if I need to wick it off. I have got wick. I normally end up being able to just drag a chunk off. There we go. Don't want too much on there, but I actually don't want too little. There we go. Yeah. Yeah, I'm happy with that. Okay, so we've just put the lead free on just to keep it nice and clear. And then we're going to put some more flux on, and then we'll float him on, and then I'll touch him up in a moment. Did I pull the pad off? No, the pad's on. It's a big earth pad on this. The pad is fine. The pad next to it was gone already, so the other pad was gone already. The concentrated nozzle key, you won't want to heat the whole board. Yeah, you're always going to get heat into the whole board. I can put a smaller nozzle on if I have to. I'm not... You can change stuff all of the time. It's about being comfortable with the tools you're using. The nozzle I've got on this is the size I use for doing various jobs. I can change it down here. I can go to a smaller nozzle here. We can go on to that smaller nozzle there if we want to. You're going to get heat in the board. You don't want it everywhere, but you're going to get heat in. But look, if I wanted to, I could... Oh, what is that at the moment? We could swap him over to a smaller nozzle just for doing this UFL. But again, when you're doing multiple different types of repairs at the same time, you just better being comfortable with the tool you're using. There's no right or wrong on these things. It's about using what you're comfortable with. The size of the end, same as the soldering iron. I actually tend to use a much larger end on an iron than needed. I'm more comfortable with a larger tip. I've got lots of smaller tips here But again, so I'm just trying to get the bloody angle right now. It's about what you're comfortable with. Sorry, let me just get it off and rotate. Again, this is why you don't want to mess around with things too much, because you end up losing where you were. There we go. That's better. Okay, so let's get this UFL that we took off. When I find it, it's just vanished on me. Oh, one moment. The UFL we had has just decided to get up and walk off. I popped it down to the one side nicely, and it's not there. I got a broken UFL here. Second, did that actually dive off the bench? Let me just check. I popped it down. I'm just checking it's not attached to me. Which it's not. Just checking around. That was a bit unexpected. If not, I'm going to have to pill another one. That's what happens when you're doing these things whilst talking at the same time, you see. Oh. Is that it there? Sorry, I've got something over here. Nope, it's not him. Where did that just vanish to? Where's that just vanished to? We have literally just had it vanish in front of us. One moment. I'm just checking on the floor next to me to check it hasn't... Yeah, it did. It bounced off the bench, look. It's frustrating. That's what happens when I was changing the nozzle. Okay, so there's some nice lead solder on there at the moment. Let's get the UFL on. Figure out the orientation. I wish my tweezers would stop holding everything I'm putting down. My tweezers have a habit of literally grabbing everything and holding on to it. There we are. There we go. That's good. It's in place. And what I'm going to do now is go in from a bit of a distance. Now, because I've changed the nozzle smaller, the air is going to be a bit more directed now. So I might drop the air down a tad. I don't want to blow the connector off. And that's another reason I often use... see, this is the thing. It's one of the reasons I often use a larger nozzle. And it is because you can actually put a component in place, keep the air at a reasonable level, and not actually have to worry about it blowing things around. So what we'll do now is just get this in the right position. 1 second, the board is twisted on me, which means... Wait there, 1 second, let me just get myself comfortable again. And again, whenever you're doing something, make sure you're comfortable. Sorry, you're going to hear the air. You're going to hear the air as I... I'm going to go a bit higher up this time. There we go. Ow, 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 ow. My finger was in the way. See, I've swapped the nozzle and now I'm having trouble. I've done 3 of these today already and I was fine. It's always the same. Swapping the nozzle is asking for issues because I've changed the flow of air. Right, okay. Get in there. Stay there a minute. Thank you. Right, okay. Now what we'll do is we'll flow it, reflow it. Now I pinned it down. What we can do now is reflow it, let it settle, wobble it in place, wobble, 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 and then let it cool. Yeah, this one's variable flow as well. It's just because I had it tuned very nicely at about 50% with that larger nozzle. On that, I need to take it down lower. I had it about 45 there, but I'd probably go down to 30 on that smaller nozzle. Let me bring it round. So yeah, we're just letting that cool a minute. Never be in a rush to touch the boards. We've also got to fix this because we've still got this gap here to here. Oh, our board is still very, very hot. So what we're going to do on that is we're going to use a little piece of wire for that. A little piece of wire. I'm not going to use piano wire. I've got some here, but what we'll probably use is a bit of a leg off a resistor. A tiny, tiny piece we're going to need. Tiny, tiny piece. Let's try this. See what the sizing's like on this. Board's cooled down a bit now. Probably way too big. Oh, way too big. Let's cut that down again. Try this piece. How is everyone anyway? Oh, a tad on that. I'd like to nip it. How is everyone? I hope you are all safe and well with everything, wherever you are in the world. I'll come back to the chat in a second, guys. I'm just trimming the wire. I could get a piece of like piano wire, you call it, or whatever we want. There we go. Let's have a look at that. I'm happy with that once we get it placed. And this will be done with the iron. You can see my tweezers, everything sticking to my tweezers. Drives me crazy. Okay, stay there. Happy with that. Okay, so what we're going to do is try and get a tag on this. Okay, so now we've got a tag on that. 1 second. 1 second. Right. We'll get that in the right place now. Let's get the tweezers back again. And just get it where exactly we want it. Now I've got some really thin tips, but I prefer to work with slightly larger ones. To be honest, I tend to... Here we go. Sorted. So what we'll do then is we'll clean that up. We've not had a lot of heat on that now, so we should be better. Get a brush. Come back to the chat now and say hello properly. Isopropyl alcohol, so we're cleaning the board with isopropyl. Put a bit of heat on that just to flash that off. There we go. So as you can see, we've got the new UFL on. Now we'll see now if there's any other issues on this board, because it was saying there was. But as you can see now, we've got the new UFL in place. We've got the connection coming across just to bridge, nice and solid, just to there. That should be absolutely fine. So that is that all nice and replaced and ready to go. What we'll now do is fire it up and actually see if it works. So let's find our antenna. We were going to want to put an antenna on now. Let's get our camera. let's power him up. We'll get in. It's a bit less than I'd like. 0.26 of a volt. Unless it's powering up into some silly mode, I might actually have to hook this up to... Oh, 0.6. Ooh, that's a bit better. Where's my goggles gone? Let's have a look. Now, obviously, I'm not going to be able to confirm the RF performance at this point, but we'll be able to have an idea of what's going on. It's not locking straight on like HDZero normally does. So I'm going to come out the menu. Just trying to scroll through the chats just to see what it's doing. Right, I'm getting video on one channel, but it's like very low. Oh, yep, we've got temperature on the PA. I wonder if it's saying something like thing mode. You know what it's called? Pit mode or something like that. Is this got pit mode? No, it's 25 or 200 on this, but it could be in low power mode. Okay, what we can do is we can cheat. The only other thing we may want to do is do a firmware update on it as well, just in case. I don't know how old this VTX is. There is a possibility this VTX is on very older firmware as well, and that is always something to watch, especially when you're fixing them, because they may not always be on the latest and greatest firmware. So what we'll do, we'll do an upgrade on it first. Let's do the firmware. Let's come back up to the desktop a minute. The camera angle's not great today. I haven't really messed it. You can see what it looks like in you with the light in the day. It's a horrible look. Yo, Failsafe, how are you? So what we'll do a quick firmware update on this VTX, just in case it's on very older firmware. And the reason for that is, for those of you who don't know, let me just get a fresh battery for the goggles. The reason we want to do that is because some of the early firmware versions actually have a different channel layout. Things don't work the same. They don't power the same. They don't behave the same. So it is worth making sure that when you're going to test it, that it is on the same level of firmware. Oh, shit. That's not meant to be happening. I may just brick my goggles. There must be firmware on that card. What's it done? Let's have a look. Oh no, they fired up. Have they? Started updating the firmware on the goggles. There must be firmware on it. Oh, no. I'm going to have to flash the goggles. Okay, I'll tell you what just happened there. I have happen to have firmware on that SD card for the new air module, and it started to flash the goggles. So I need to download the firmware and re-flash the goggles first. I just bricked my goggles. That's fantastic. Oh, God. Okay, so let's get some new firmware, shall we? Let's do the goggles first. Let's see if it'll take it. Let's see if it will do it. I'll come to answer some questions now. Just catching down. Good as new. Yeah, it looks good. What we'll do is we're gonna have to reflash my goggles a minute because I just bricked them completely accidentally. But we might get away with not needing to do the recovery, if I'm lucky. If I'm lucky, I won't need to do the recovery. It might just take it. So always be aware of that when you're putting firmware on a card. Make sure you delete it afterwards, extract files here, Scout HD. So we'll do the Scouts. I could always put the other module on if I have to power that up, but let's just get, we want that unplugged, that plugged in, and then let's have a look. Oh yes, there's definitely firmware on this. We definitely don't want that. Go away, go away. Oops, what's the chances of that? Of all of the SD cards I picked one with firmware on for a module. What's the chances of that, eh? What's the chances of that? So, let's flash the goggles first. Please recover. Yay! Come on, is it going to do it? Reading file, writing. Let's give it 2 minutes. We'll get the goggles working, and then we'll do the flash on that. So always be careful with your firmware. Evening, good to see. All the time. Trust me, just all the time. All the time. Yes. HDZero at the moment will blindly flash whatever it takes, but you're not permanently bricked. You can always do the recovery process. The firmware flash recovery always works really well. But yeah, it'll flash the module firmware. So mine is over here. I've been testing this one, the new one, and I had that firmware on the card, unfortunately. It's just writing now. Right, done. It's interesting. Oh no, it's still writing the rest of it. I'm afraid my DJ had a dead battery. Yeah, what I've probably done is put the firmware on a fire card and then not actually done the flash. I was going to do something and not do it. But the chances, yes, writing is fine. It'll recover now. The chances of making a mistake like that is very low. Do you know what I mean? The chances of you having another firmware file on a card. So we'll let that do that. We've got that one on the overhead. So just to show who those have just turned up, we've just done a UFL repair and a bit of a wire repair on this one. If I just rotate it, I'm going to shut that down as well because that's getting very hot. We've just done a UFL repair and a wire repair on that one. That's the second one. I've noticed companies just use it, so it's storage. Menace patches are okay. No issues with them so far. They're looking really good. Really good indeed. Sorry, I forgot I'm on that camera now. So far, so good. No major issues with the Menace patches whatsoever. Yeah, it's quite a slow flash on the HDZero goggle. It really is. So what we'll do is, actually, no, I got to wait for this because I've got to unsolder the power. And I don't want to unsolder the power to resolder the power because that's going to be a pain. But what I will do is I will show you a VTX which is damaged and show you quite a common issue on these. It's this one here. Just making sure I got them in order. I think it's this one. I'm going to show you this. Now, I have talked about this before, but this is damage that can happen on these VTXs. Is it this one? Yes, it is. Okay, so here we have a VTX that will actually work if you put your finger on the MIPI chip. Now, if I hop over to the microscope, just to show you, we'll pop him out the way a moment because I don't need power for this one. We have here another race version, but this is the newer version with the smaller MIPI chip. Now, this is the MIPI interface I see here. So for those who don't know the layout of a HDZero VTX, we've got the MIPI cable, comes into the MIPI IC, which does all of the configuration and control for the camera. It then goes into the main IC, out into the RF front end, into the power amplifier, out to the UFL. Now, this one has got a problem that when you press on this, it works. Now, they're using a double daughter board here, and the reason for that is earlier VTXs, let me just find one to show you. It's not that one, not that one, not that one there. This one here. So earlier VTXs had a larger chip. Okay, so you can see it there, the Toshiba 358748XG, I think it is. So that's that chip. That is the same chip, it's just a new smaller package. So what they do is they use an IC board converter. So all this is, this board around it is a conversion board from the one size to the other. And so this is the newer one which has the smaller IC like that. So rather than redesign the whole PCB, they've been able to just fit this second board. So you can see it's a board on a chip, on a board, on a board. Now, if you look closely, I can actually show you what is wrong with this one quite easily, because if we get the camera focused properly and go in there, the fault on this one, and now you guys can see it, is that the MIPI IC is cracked. There is a crack that runs from that corner all the way down to there. I put a bit of pressure on there, you guys can start to see that open up. Now, believe it or not, the IC will actually still work somewhat. Not perfect, but it will work, but it will then play up. Now, this is caused by one thing, and that is generally people using a clamp or a cable tie to hold the MIPI cable. So the MIPI cable on this one actually comes out this way, and there's these two holes here that HDZero recommends you put a cable tie through. And what actually happens is you're running a cable tie around this area here and putting pressure on this chip and actually crack it. And this is quite a common fault. So much so, one VTX that had a cracked chip, 2 VTX that had a cracked chip, 3 VTX that had a cracked chip. So this fault is common. Bollocks. Sorry, I was on the wrong screen. Unbelievable. The battery just went flat. I knew it was a low battery, but I didn't think it was that low. Just went flat halfway through the recovery. Unbelievable. Now we are definitely going to have to use the recovery process. Let me just grab another battery to see if it powers up. It might have finished because I wasn't actually watching it, so it could have finished. If it's finished, it might be okay. Let's just power it up and see. That'll be no. Don't use batteries to update HDZero. We'll do it on the power supply. Has anyone seen the recovery process before? I'm about to show you. It's not too bad. It's not too bad. What we'll actually do, shall I just... You know what, I'll hook the goggles module up and I'll hook that up and do it with that. Okay, so we need the firmware files again and place them back on the card because it's not happened properly. These things always happen when you're trying to do something. Are UFL issues due to unsecured UFL more common? The main reason I believe we see UFL issues is because of the soft solder on HDZero. Not specific HDZero, that's the wrong term to use. Soft solder, lead-free solder is just junk. It really is junk. They are so soft, and the pressure will just rip the UFL off. It really will. It'll just rip it straight off. So what I'm going to do now is I have an adapter for my bench supply. So we'll do it on the bench supply. So to do the recovery on a Scout HD, we're going to have to move the switch, first of all, to the right position, which is in here, which is a horrible place to see on these goggles, I will be honest. There we go, moved it forward. Recovery is forward on these, normal is back. We'll go on the bench supply, make sure it's wired white. There we go. Let's put it on 12 volt, current limited to 3 amp, fire up and let that do its thing. I'll keep an eye on that, put that there a minute. Sod's law, innit? Absolute Murphy's law. The chances of a LiPo going that flat. I picked it up off. Always goes around. I would, a dab of silicon. My advice for securing the MIPI is a dab of silicon. Just checking if it's kicked in yet. We'll check that in a minute. So if I go back to the overhead, so you can see it's cracked. So that's the cause, the cable going through there, and it cracks the IC. Now this can be changed, but it really isn't easy. I don't have stencils for these. It's not a job I undertake lightly because I've had one success and a couple I haven't. I'm just checking the recovery process has started and I'm not convinced it has. At all. You sometimes get this funny behavior, the switch, you move it into the right position, but it doesn't kick in. Try it again. Just waiting to check the LED I am. It might be that there are times, right, and I've had this before with HD, is that HDZero is it doesn't like the card sometimes, especially on the software recovery process. I don't fully understand why, but there are times where it doesn't like the card. If this doesn't work, I'm going to put a HDZero. I'll do it via the module, and I'll fix these later. Yeah, it doesn't like the card. I can see it already. It's not touched the files. Let me try this one. If you ever get problems with HDZero on recovery, swap the card. Is always the best piece of advice I would give. The other trick to it is format the card in another goggle. Ooh, that one's not picking up. Should we try a third card? It's warm here today. I'm just waiting for my cards to appear in my drive. Why are my drive cards not showing? Thank you. Okay, let's just see what that's done. See if that does it. It does do weird stuff at times. Okay, plan B. Where's my 04Xs? One second. You get this happen. Sod's law will always be it doesn't want to play ball when you want it to. So what should happen is the LED should come on next to it. So what we're going to do is format this card very quickly in my 04X module, my actual flight module. Oh, there's a card in there already. It might be formatted. If it's got files on it, we'll be good. Let's have a look. He has. Okay. Okay. We'll try again. It's something worth noting that on HDZero, if you do get problems with recovery, the SD card is normally always the reason. Right. Now, see, it's kicked in. Now I've got a red LED. Good. Okay. And it's always the SD card. It's always the SD card. If you ever get a problem. Every single time. Right, I'm going to flash that now with this one. So what I'm going to do is format this card in this. And we'll do the update on the VTX on this one. Is what we'll do. While that's doing that, we'll use this to do this. The good thing is flashing the VTX is super fast. Super, super fast. It's one of the good things with HDZero. It doesn't take long at all. So we'll do that and then we'll hop on to the next board. Turn the 04X's on. Believe it or not, I'm on analog because I was flying analog the other day. Right, we need to go into the menu. We'll format this card. We'll put the files on then for the correct VTX. Skipped past the correct option because I hate the menu button on HDZero. Drives me nuts every single time. There we go. Okay. So we formatted that SD card. I've left the goggles powered up. So we're going to put onto this now the correct files for the Whoop VTX. So I haven't done them. Whoop TX5 S.1. Cancel that. So I want to extract to there. And then we'll put the Whoop files on for the VTX. Whoop. Extract files here. And it's just HDZero.tx. So that's the only thing we need on this one. So we'll put that there. We'll delete. Oh, God, there's firmware files on this one as well. How's there firmware on this? I just formatted that. It's interesting. Just formatted that card. I was expecting that to be blank. Okay, interesting. There we go. So, on here now, we have the Whoop files. So what we'll do is get the card in. Now, if you don't know, on HDZero, you don't actually need to power the VTX to update the firmware. The VRX module will update it for you. So what we're going to do is just get it into the right place. This is the worst bit. Power the VRX module. It is a bit of a faff, this process. Yeah, it's writing. Just waiting just to let it do that. The only problem is I can't power the damn thing up now because I'm using the power supply to power the goggles that I bricked. There we go. So that's written the firmware to the VTX. We're all done. Cool. So that's all I wanted to do. That whole process was all to do that. Unbelievable. Unbelievable. Okay. So, we have the new firmware on this VTX. My other goggles are currently recovering, so we've got to wait for that one. Okay, let's battery power it. And let's see how it works. Let's battery power it and see if it works. So we'll get the antenna back on. I'll power these back up. As the receiving goggle, we'll do that. This is the receive for this one, and then I can test if it's working. We can have a look. Just grab another battery. One that's actually got battery in it. We've killed one light bulb tonight. Oh. Okay, so we'll do it on the bench. Just a quick and dirty bench power up. Here we go. And let's see what it does. Turn it to scan. Is that actually powered up? Just check that it does power up properly. So I'm doing it a little bit dodgily. Let's do it off the balance connector. We're sticking wires in holes here to get it to work. Not the best way of doing it, but come on, play ball. There we go. We've got the camera on. Let's see what it does. There's definitely something. Ooh. Oh, hey! We have video. Can't easily show you guys. Camera colours all over the place. What's going on there? What sort of colour's that? It's weird. Let me just check something. 720p original camera. Yeah, very random. There's some strange setting. There's no settings on the VTXs. I suppose actually no, it's not bad. No, it's not bad. It's me. It's the white balance as I'm looking through it. It is cool. So we have video. That's working absolutely fine. Let me just put the overhead on, show you guys that. Is it going to work? Yes. So I know you guys can't see easily, but you can see my hand moving there. There's video. It is working. So I'm happy with that one. I think that one's going to be okay. I don't think there's any damage to the PA. I don't think there's anything particularly massively wrong. So what we'll undo now, they get very hot, is we'll just solder the wires 1 second. I'll be back with you. And then we'll take a look at another one. And I want to talk to you about a new fault that I have found on some of these VTXs that I have not seen before. Oh, the light's gone off on the Scouts. Are we off? We are officially off, ladies and gentlemen. Are we recovered? Oh, bollocks. Not followed the process properly. Put the switch back. Is me tweezers gone? Here we go. Hold them back up. I've done that before and I'm usually fine. Hey! So we've not only done that, we've recovered them as well through my shocking actions of bricking my HDZero goggles at the same time. Okay, Mads Tech, is there a tutorial mod explaining how we can install HDZero on non-HDMI goggles? Many of us own box goggles. My personal catch. Without HDMI, there's no reasonable way of doing it. Yes, you could use a analog to HDMI converter, but you're just adding latency. It's just not a reasonable solution. It really isn't. It's not a solution I recommend at all. It really isn't. So just to show you the final repair on this for those who've turned up very quickly. So this one had a damaged UFL and it wasn't working properly. We've now upgraded the firmware. We've now done a replacement UFL and a small bit of bridging wire as well, just to make sure that it is connected properly. So that one is now done. That's the second one of these I've done. There was one here which is much worse. I will show you that one in a moment. So that's that one. That one needs to go there. There's one we've done which was a lot worse from a repair point of view. Was it this one here? Let me just have a look. Yes, so there was this one. And then this one, another one with a broken UFL, but what we've done on this one, it's a much bigger repair. We've had to put a larger piece of wire in on this one, just along to there. But you can now see the UFL repaired on that one. So that's that one done as well. So we've got two. Now, the next one I want to talk about is this one here. Now, I've come across something on two VTXs already, which I have never seen before, okay, in diagnostics. And we're going to run through it on this one. And I'm also going to be probably doing this as a video as well. Now, what I'm going to do is I'm going to come back full screen a minute just to show you this, and because I'm going to do this as a repeat. You're going to do a bit of Lewis Rossman now. We're going to do a little bit of Lewis Rossman. So you're going to have to put up with me doing a bit of thing. Good afternoon. Today we are going to be taking a look at this, a HDZero VTX, and we're going to be doing the diagnostics on it and hopefully diagnosing what the issue is and try to walk you through the solution to fixing that. Now, I've spent the day doing repairs on HDZero. I've done a bunch of VTXs here. We've had UFL repairs, and I've had two VTXs already with very similar problems to this one, but I have left this till now to be able to do the diagnostics and then the repair to see if this issue is the same. Now, all of the boards I've been looking at today are Whoop VTX boards. They are not the traditional larger style. They all have varying different firmware versions, but there has been a trait on some of them that we know you can easily damage the MIPI connector and or the MIPI chip, but this is something new. So what we'll do is head up to the overhead. We'll take a look at it first of all, and we'll start doing some diagnostics, and then we'll walk through that process. And I've cut the recording there, see. Okay, so I did that off the top of my head. True professional, you find. A true professional I am. Okay. So, we need to get the overhead in place. There we go. Let's get this camera right. Oh my gosh, what are you doing down there? What did you do that for? That was silly. God, I don't know, you lot. Put you in a nice place and you jump off. Unbelievable. Unbelievable. There you go. Okay, so the first thing we're going to do, guys, we have the board, and what we don't have is power. So we're going to hook up some wires so we can get it connected. We're not going to be messing around with a LiPo. We're going to be using it on a bench power supply, which will have a current limitation as well, so we don't set anything on fire. What we're going to do is get over to this side here, and we're going to solder on. Oh my God, that's blurry. What's going on here? There. And now you're blurry. Whoa. There we go. Okay. So we're going to go on there. And our ground there. So we're going to turn the bench supply off. We're going to set the preset to 8 volts. And I'm going to set the current to 1.5 amp. That way I know if there's anything dodgy going on, we will trigger the overcurrent protection on the power supply and then prevent any issues. Now, I'm going to power this up without anything attached because I just want to see quickly what goes on. Do we get the LEDs flash is the first port of call. So we're going to hit the power. We've got 8 volts going in. You guys can't see it, but there is no current draw at all. And if you notice, there is no flashing light on the VTX whatsoever. So if I'm going to put my finger on, nothing. It's cold. There's no life, no power, nothing, no power lights. So the first thing we can start doing is having a look at checking the various power ports on the VTX. I've got a multimeter here. I need to get an on-screen display multimeter so you guys can see it because it would be good for you to see the readings. But what we're going to do, we're going to check it in voltage mode. Because it's powered up at the moment, we're going to have a look at various places on the board. So we're going to just check down here. I know that's a bit out of focus. Let's just get that sorted for you. What's going on here? My focus is all over the place today. That's better. There. So, that's not right. There, we'll go there. So we're going to check power on the input. Okay. Down to ground. What's going on here? I'm not getting input. What's going on? On DC volt? Yeah, we're powered up. Sorry, I got something odd going on. Let's try this again, shall we? Okay, what's going on my multimeter? My multimeter's not picking anything up. What? My multimeter's just got on the spats. I'll have to get the bloody power supply one out. Do I own a thermal camera? No, I wish I had a thermal cam. Sorry guys, I'm just diagnosing what the bloody hell is going on here. We have just lost input on the multimeter. Oh, no we haven't. I'm being a complete tool. We haven't got power going into the board. Now we've got power going into the board. So I'm going to have to do that again now. It's your fault. It's your lot's fault. Distracting me while I'm doing things. Okay, so I've powered the board up and we've got 8 volts going in and it's drawing no current. Still no power at all. And as we can see, the no flash on the LED and nothing is getting warm at all. Nothing whatsoever. There's no heat there at all. So we're going to start doing some tests. We're just going to check we have got power coming in. Just now we didn't. Now we have 8 volts. Perfect. We have 8 volts coming in on the pads. Now, on these VTXs, there are voltage pads located all over. You can see there's one here. You can see there's one down here. There's a ground pad here, 1.2 volt there, 3.3, and 5 and 5 volt. So, the first thing we're going to do is check these pads for voltage. So, we're going to check that 5 volt pad up here. We have 2.1 volt on 5 volt. We're going to check that pad there. 1.9 volt. That's not looking good. We're going to go down here to the 1.2 volt area. 0.1, 3.3, half a volt, and we'll go to that one there. Yeah, nothing at all. So whilst there is power coming in, there is no voltage whatsoever. Now, the setup of these boards is that the power comes in. If we flip it over, and I'm going to power it down a second, just for safety, zoom in and focus a minute. So you can see the power coming into here. It comes through that diode, and then it flips over to the other side of the PCB, goes through a coil, comes back through into this area here, which goes onto this capacitor and into this leg of this IC. So if I rotate this, this is the 4202 IC, which is the voltage regulator. So the voltage comes in, goes into that pad there, comes out of that pad here into the coil. So you should have at this pin here on this IC battery voltage, or as close to battery voltage as you would expect. And also on this part of the capacitor here, and also on this diode. So if we power this back up, I'll walk you through what we're getting. Now we can do this in continuity, but what I'm going to do is do this manually. So we're going to look here, first of all, and we should have battery voltage. We do, 8.8. On the flip side of this diode, we should also have battery voltage, roughly 7.19, absolutely fine off the 8-volt voltage drop. So next, we should have as close to that battery voltage as possible on here, here, and this pin of this IC, because they are linked. So if we go to this pin, first of all, we should be getting close to battery voltage, and we're getting 6.25. Interesting. Less than I would have expected. If we go to the capacitor, 6.25. If we go to there, 6.25. So we're getting some voltage to here. On this pin, we should be getting voltage output of about 5 volts. Maybe 4.5 to 6 volt is what we should be getting, because that is what goes to this leg of the coil, and on that side of the coil you should be getting a straight 5 volt output. However, I am on this leg of the coil here, and I'm only getting 2 volt. So we're getting at that pad, oh, that's interesting. Whereas earlier I said to you I was getting, what am I getting there now? 2.15. Here, oh yeah, we're getting 6 volt again. Yeah, that's fine. So the voltages, in my opinion, are not right. That isn't right. That's down to 4.3 volt. Yeah, there's something going on. Now, I'm not comfortable with that 6 volt we're getting here. Something is off here on this. I would expect more voltage than that. We should be getting full battery voltage at this point here. Just to give you an idea, and if we wanted to say confirm the voltage we should be getting there, we could pick one of these working VTXs and check that, but I'm not going to do that on this. I know we should be getting more than that. So the next set of tests we're going to do is some continuity ones. I've powered it down, so there's no power now into the system, and we're going to now check the voltage coming through the coil. Now, I've had a fault earlier on already, which I've never seen before, which is the coil actually burning out. And we're going to see if that's the case. So we should have some form of diode continuity through here. Perfect. We're on diode check. And if I go to the diode, yeah, 0.9 volt. And that's fine. And then from here, okay, to here, we should have continuity. And if you notice, we haven't. You should be hearing a beep, and there's actually 249 ohms there at the moment. Now, that is not right. That is not right at all. So, I am suspicious at this point that the problem, and let me just get my wires unclipped so it's not putting pressure on where it is. I'm actually suspicious that this coil has failed again, and this will be the third one of these I've seen today. So the way the voltage comes in, just to explain it again on this VTX, it comes in down here, through the diode to this pad here. It then goes through the PCB into this leg of this coil. This leg of this coil goes through to here, and then that side returns back to this area down here. So what I'm suspicious of is this coil is open circuit. So what we're going to do first of all is we're going to get that off, because I'm not comfortable with that, or it's at least not right. Now, if we try and pin it, it's going to be quite hard because it's a very small surface mount component, but we should be able to get in there. We should have continuity there now, and we don't. We really should have continuity straight across that coil, but we don't. I am highly suspicious that coil's gone. Before we lift it though, let's just clear up around that there, and let's see if we can look in closer. Let's just clear it with isopropyl a minute. And let's see if we can see anything, shall we? Let's just get a heat on it. There we go. And I can see something already, but I don't know. Let's have a look. So what I'm going to do is pop this up so we can see the coil. Okay, so we can see the legs on the coil. Look at that. Can you guys see that? I think that's the coil burnt out. I think, this is hard to hold for you guys without it wobbling. I do apologise. Let me grab my tweezers, which have vanished on me. I think that coil is gone. Why is it your tweezers always vanish the second you actually need them? There they are. Right, let's just get the tweezers and have a look. There you go, look. You can see the coil's burnt out. There. Completely gone again. Let's get back down. So we have a situation where the voltage comes into the board, goes through the diode, through the coil, back down to the TVS style protection diode, and then into the system, but the coil has burned out. Now, this is the third one of these I've seen today. If I just do this, I don't know, will this play back, actually? I took an image earlier of another one. I don't know, actually, this camera can't play back, which is frustrating, but I have done already. So, the first thing we need to do is get this coil off. So, what we're going to do, we get some flux on him. Come out a bit. We don't need to be quite that zoomed in for doing this. There we go. We're going to orientate the board so it's comfortable, because again, whenever you're working on something, you want to make sure you're comfortable, not the component. There we go. We'll get some hot air. Going to very carefully go in. Our wires are desoldering themselves because because this is quite a large component, it will take a second or two before the solder does go. Here he goes, sorted, all removed. Now, things asked in the chat, why do I think the coils go bad? I don't know right now. I'm not 100%. Just wait for that to come. I'm still not 100% sure why the coils are even there. I think it's some form of voltage protection. It's not common in stuff that I've done a lot with, that we have coils on the voltage input area. You'd have an inductor. An inductor is used as part of filtering. It's like a capacitor. It can be used as a filter. You know, it will resist changes. It builds up a magnetic field. and it holds that magnetic field, and then it lets that magnetic field go when the voltage drops. So if you take a capacitor, for instance, a capacitor resists changes in voltage, and an inductor basically resists changes in current. So a capacitor is really good at smoothing out voltage changes because it's absorbing them. And an inductor sort of works the same in the sense of it will absorb that energy and put it into a magnetic field. But when you power down, it will then release that energy from the magnetic field into the circuit. So it can be used as a part of filtering in safety circuit. But there's clearly something that is causing these to burn out. Now, it's probably going to be in a crash. Out, that board is still hot. There's probably some form of overcurrent or something like that that's going to cause it in a crash, and that's what's doing the damage. Now, we've got two options here. Number one is put a new coil on. Have I got one? Yes. Option two is actually bypass it. Now, I've done that already on one board. For this, we'll put a coil on, okay? So we've got another spare board here. Let me just check. Actually, no, that isn't one I want to pull it off. We've done it off that one. What about this one here? I think, yeah, we'll go off this one. We'll borrow it off this board, and then we'll go from there. Okay, so the first thing we're going to do is just get some proper solder on that pad. None of this lead-free nonsense. We want some proper solder on these pads. So we're just going to put a, leaded solder. We don't want much. I don't want too much. I just want to make sure that there's a nice amount there for when we add the flux and the new one, it's going to go on properly. What we're going to do next is borrow one off this board here. So we're going to want flux. This board here has some faults. So we're going to want flux. We're going to take the air down a bit. It's still a bit high in my opinion. I don't want it moving things around too much. So we're going to grab him off this board here. Now, because we're using leaded solder on this board, it's going to be a bit more challenging to get off that original board. We're going to use flux. We want plenty of it as well. There we go. Again, as I've said earlier, I don't use the same sort of stuff Lewis Rossman and stuff uses. I tend to use this stuff. There we go. Starting to settle now. Wobble him a little bit. Here we go. He's a little on his side. There's a bit too much solder on the pads, but I'm not particularly worried about that. Better than factory. Better than factory. I do watch Northbridge. Haven't watched him for some time. I tell you what, he is a clever bloke. And what I like about Northbridge is he does a lot of product. He doesn't just do MacBooks. Lewis Rossman is fantastic, but they're very specialized. What I like about Northbridge is he is cracking at anything. He really is. He really is having a crack at anything. I'm just waiting for that to cool down a little bit before we hit it too hard with some isopropyl alcohol. Tipping my isopropyl alcohol over my desk. The good thing with tipping isopropyl alcohol, you can still see how hot that board is, look. It's boiling off. So it takes a bit of time for the boards to cool. I do usually have a fan on the bench. Okay, cool. Happy with that. So we'll just let that flash off. Sometimes just a bit of heat helps. Just flash it with a bit of heat. Flash the bench with it. Flash, 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 flash. There we go. You can see we've now got the coil on. So what we'll do now, I'll just wait for that to go off, and we'll do some of the continuity tests again to show you what we should be getting now. And then we'll do the voltage checks, and then we'll see what the board does. So we've got continuity. As you can hear, we'll just wait for that to pan down. So the first thing we'll do is we'll check either side of the coil. And when we need to do that solder on that. Look at that, the two wires are soldered together. Like, we need to adjust that in a minute, but we're okay in a minute. So what we want to do is check both sides of the coil. So we should now get continuity somewhere like there to there. There we go. Good news. Okay, we weren't getting that just now. So if you remember earlier when I said we were doing our testing on this board, so what we should have is we have our diode circuit, which is there, which is fine. And then what should happen is it goes from here through the coil and then it reappears here. So we should now get continuity here. And we do. So we weren't getting that earlier, but we are now. So what we will do is resolder our wires, because we don't want to turn that on like that, because that's asking for trouble. One. Oh, Jesus, something made me jump. Oh, we've got a super chat. The super chat noise made me jump. Okay, I will reply to that super chat in a moment. Let me just get this done. Here we go. Not the best connection in the world. It doesn't matter at this point. I'm not worried. So we want our positive. We want our negative. Where are you gone? You're here somewhere. There he is. We'll zoom out. And what we'll do first of all is we'll have a look if we've got power. So we'll look at the power lights first of all. So you can see the lights there. We'll go 1, 2, 3. Well, hey, we have power LED. Hopefully you guys can see it. We've got red. So if I just power that down a minute, and then what we're going to do on down here is just check what voltages we're getting, where I would expect to get them, and then we'll check the test pads and confirm them as well. So we'll go back onto DC volts. We'll put some power back on. I don't want to do it for too long, so I haven't got an antenna. Actually, let's just put an antenna on this. Now that it is powering up, let's put an antenna on this. It doesn't need a camera, but the antenna will be a good idea. There we go. Okay. There we go. Sorted. So we're drawing 0.11 of a watt, 0.11 amps, which is fine. So what we're going to do first of all is we're going to have a look at what we're getting here. Getting 4-5 volt there, 5 volt, 4-5 volt there, a bit less than I'd have thought. Okay. Oh no, sorry, my ground wasn't in. Let's try that again. 7.83. 7.83, much better. On the first pin here, we should have that 7 volt again. We do. And then on the output, we should be around 5 volt. 5.446. And on this side of this coil, 5.388 exactly. If we now spin the board over and look on the test pads that I spoke about earlier, so we've got a couple down here. So if we take a look at these test pads, we've got a ground pad here, but we can use that there as the ground. So we've got 3V3, so we should have 3.3 volt here. Just checking, going off the ground. That's interesting. Okay, 0.3 volt. Interesting. We haven't got the camera attached, mind. I wonder if that's the reason. Okay, we're getting 5 volt up here. We're getting 5 volt there. Let's just turn it back off and put the camera on, because there may be some differences when the camera's not connected. Let's just try that again, shall we? And what we should start to see is also a bit of flashing on the LED. It's taking a little less current than I would like, I'll be honest. I would like to see a bit more current from this one. So what are we getting? We're still... might not be over yet, ladies and gents. 0.3 of a volt. I don't think we're fully fixed. Definitely not. So we've now got power, but we're not getting the voltages we would expect them to be, which is interesting. Let's just check what we're getting down here. Interesting. Interesting indeed. Just checking around. Okay. We'll just come back over to this side here and just do a few more checks, because we've got multiple regulators in this thing, so you do need to be aware of that. You're not just going to be... What's going on here now? Let's check this. 5 volt. We're definitely getting 5 volt there. Okay. So we're definitely getting the correct voltages there. 8 volts going in. I'm running off 8 volts at the moment. We can go up to 10 or 12. She should run on 8 these. I've ran these on 8 volts without any problems. We could go to 12. There we go. Let's go to 12 volt. Let's put some proper current in there at the moment. There we go. Okay, so we're just going to do some more checks again. Yeah, we're definitely not right. We're definitely not right still. Oh, hello. Okay, so you're 1. You're 0.7, which should be 3.3. We're getting 5 volt up there. We're getting 5.3 there. So the 5 volt rail is fine. We seem to be down on the 1.2 volt rail. We seem to be down on the 1.2 volt rail. Interesting. Okay, so we're not over yet. Now, I need to figure out where the other rails are on this, because I'm not 100% where they are. We've got multiple regulators on this thing. So you've got a regulator here, you've got a regulator up here, you've got a regulator here. So there are lots of different regulators on this board. I'm just trying to look around. So if we just pop our MIPI connector off a moment, and we just have a look around, we've got... Okay, so we've got this IC here. I don't know what that IC there does. I've not been able to identify him. He's got a lot of caps around him. IAEDM. It's one I've not been able to identify. Docs on 100. Thank you for the super chat. I really appreciate it. Shouldn't you not turn on? You shouldn't turn on without the UFL ideally. For a second or two, it's fine. Okay, so we're going to throw a bit of crap at the wall here. A minute. So, I don't know what that IC there does. That, I suspect, is a USB IC. I don't think that's power. And then on the bottom of the board here, we've got this IC here. I don't know what these are. And we've got this IC up here. So I'm just looking if there's anything that looks damaged. Nothing looks damaged. Nothing looks broke. They're QFNs. The 4202 seems to be working because we're getting 5 volts out of it, so I'm happy with that. Tell you what we'll do. We'll throw some crap at the wall. And I think we'll swap him out because I don't know what it does. And that's an easy solution to go for. Just Paul B. Harper, my lord Ian, surely you've been repairing an awful lot of HDZero boards. I'm wondering if maybe an issue looks like a job at factory. It's digital. I will say something on this. Digital FPV is far more delicate than traditional VTXs. Not HDZero specifically, just there is more to go wrong. And what I mean by that, we'll look at now. If I show you this, we have 5 different voltage regulation stages on this. So it's not just one regulator, it's 5. You've got the MIPI chipset, you've got all of this additional stuff that adds together to give potential for problems. And it's not that I think HDZero is any more brittle or less resilient, it's just more to go wrong. And DJI is the same. You know, I've had a number of DJI VTXs burn a hole through their PCBs, just completely annihilate themselves for no good reason. And I still don't fully understand why. We're just going to lift this a second off this board. This is a bad one. There we go. Yeah, there's just more to go wrong in digital, and it's worth understanding that. It's worth being aware that in this situation, you're gonna have potentials for more things to go wrong. And that's just the reality of it. Do I think there's more that could be done from a HDZero point of view? Probably. There's always more you could do. There is some stuff I would like to see just to help with things around the UFL, for instance, maybe some hand soldering on the UFL, just to make sure, to give just some additional protection. It's the wrong way round. Make sure I get it the right way. We're not going to do any cleanup on this. We're going to go straight in and on when I get him right. Just going to get the orientation right. Come on. It's always the same, right? If you're holding the station in your hand, you won't get it right. I don't have the steadiest of hands at the moment. Is that the right way around? You want to check it on a good one. Yeah, there we go. That is. Yeah, I don't have the steadiest of hands at the moment. I'll just check that's on, but that's not it really finished. I'll just check the pins are on okay, as long as, ow, it's hot. You forget when you're working on these things that they do get very hot. Okay, so what we're going to do is just check. That's okay. It's not perfect, but I just want to, as long as it's on, I can power it up and see what it does. Yeah, that's fine. We can tidy it in a minute if it works. If it works, we'll tidy it up. If it doesn't, we'll tidy it up and move on. There we go. Put the voltage back on. Powering back up and see if we get any more power elsewhere. I'm not exactly sure what that regulator does, that IC does. I haven't had time to delve into it. I really haven't. So, again, the same things apply. What we're going to do is we're going to wait for it to cool a bit more. You should always allow the board proper cool time. You get low resistance with the PCB when it's very, very hot. So if you've put heat into it, you should let it cool down a little bit first. While it's doing that, let's just check the chat. What's up, bot? Good evening. Good evening, bot. Mr. Grinder. Oh my God. Hello, bot. How are you, my friend? Buck regulator. Oh, thank you, Lewis. I appreciate that. I haven't had a look. That's a good start, and it's around the right area that it could have got popped on the way through. That should be all right. Okay, let's have a look what we're getting on the inputs now. Oh, 3.3. 1.1. 1.8, 5.3, 5.5, and I've just spotted something for those who haven't seen it. Blue flashy, blue flashy. Have we got him? Let's have a look. Let's power him down, connect the camera. I've still got to tidy that up. Actually, let's do that now. What I'm not going to do is I'm not going to put air onto that now. So what I'm going to do is I'm not going to put air there. We're just going to more flux a minute. We'll swap nozzles on the iron. We'll use a needle tip and we'll just tidy the pins. That's all. Just to make sure it's I could do drag soldering here, but I'm not really that keen on risking just putting too much in for no good reason. Okay. We're not actually center on the pad. We're actually off to the side a tad. But I'm not going to lose any sleep over it. At the end of the day, we want it to work. If I want to get really fussy, I'd hit it with air and float it in the middle. Shall I? No. Shall I? You can make it look perfect. It doesn't matter. It is easy at some of these stages, right, to mess around with some of this stuff too much. It's on. It's in the right place. It's got good connection. Don't worry about it. It's easy to want to go, oh, I'll get it better than factory. But you are at times asking for trouble when you do that. Just a bit of... That'll do. That'll do. That'll do. Okay. Let's get the camera on. Let's fire some goggles up, shall we? And drying the board, yeah, just from the isopropyl alcohol. So I put isopropyl on it just to dry it. You just put a bit of heat to dry it off, that's all. It'll flash off in a second, but we'll fire the goggles up. We'll wait for them to kick. We go, hit the power. Oh, sorry, I disconnected the positive when I was soldering that. Let's do that again. Do that again. Let's see what we're getting. LED wise, we should get a random flash of the blue. Not straight flash, but a random one. Trying to say I'm not getting anything on the goggles. Let me just check this MIPI connector is right. It's very easy on this. This one is quite well used. So I just want to make sure it is biting properly. I also don't know how old this VTX is, so it could need a firmware update. Let's just check something a minute. Oh, you're not in focus. Let me just refocus that. Let's just check those voltages again, just to make sure nothing's changed in that minute or two we were doing something. It has. Hello. What's going on here then? 0.3. We've lost the voltages again. Okay, hello. Just want to make sure there's nothing dull going on, is there? Okay, nothing's bridging, that's fine. Let's just power that back up without the MIPI on a minute. Yeah, see, look, we've lost the flashy bluey. We had flashy bluey and we've lost flashy bluey. Interesting. Okay, let's just go back on that again and just check those voltages. Okay. Yeah, we've lost them, definitely. These goggles draw so much power, they'll kill lipos in a heartbeat. It's a little bit interesting. Okay, let's just check something. I'm just wondering if we've got a short somewhere that we're not seeing. Current's right down again as well, which is worrying. So, no. Yes. Yes, so we're fine there. Did someone say did anyone find if you guys found the chip, can you put the data link to the data sheet in the chat? Or if you found it, let me know. Let's just see what we get here. We've got 5 volt there. 0.5 there. Something interesting is we could even have a cap to ground. So I'm just looking at the voltages. It's rather interesting. But we had voltage. And now we don't. Okay, let's just do some checks around the place. Just check anything's down to ground. Okay, so let's just have a poke around a minute and just see what we've got. Is anything here down to ground? So we got that. So if we come out a little just so you guys can see a bit easier, I'll show you what the way we'll do this. So what we're going to do is we've got a ground connection, which is there on the board. So that's to ground. That isn't, that's fine. That's to ground. That isn't, that's fine. That isn't, that is, that isn't. That is. Interesting, these big bad... What? Oh, they're not capacitors. Are they coils? Ah, they're not caps. Are they coils? That would explain what we have. We've got the buck converter. So that must be the output coil on either side of the buck converter. It's a double-sided buck converter. One way, one the other way, if I'm guessing then. And that's a coil, because that's 0 ohms. That's fine. So what we shouldn't have is any side of that to ground then. No, we don't. No, we don't. Okay. That's fine. That all looks good. So is that connected to that? Okay, so that's the 3.3. And that's the 1.6. So this must do 3.3 and 1.6. Because that's one side. So that one is coming off that end of the coil. And then that must go to one of these pins. That's output. That's input. We already know that's input because I'm getting that from the 5 volt over here. Okay, so we know that. That's input. That's output. That's probably output on that side. Yes, it is. Is that input as well? Dual input? No, it isn't. Okay. Intrigued. Intrigued. If I was a betting man, I'd say that's gone down. Let's just float it. 1 second. You can get weird stuff. Right? Okay, let's get some tweezers just in case I need them. Just in case there's something dull on one of the pads, because we had it until I touched it up, didn't we? So let's just... We've got some nice bridge in there now, which I'll fix in a moment. I'll fix the bridging, don't worry. Let's just let that do that. Oh ho! Thought of something. No, there isn't. I was on checking. No, it won't. I'm guessing it's a double-sided buck converter. Lewis, are you on my Discord? Can you post it on my Discord? Pluck them off with tweezers. Yeah. Right. Let's just tidy that up a minute and sort that a sec. Ow, that's hot. We have a bridging pin now, which is fine. Which I'll sort now. Okay, so what we'll now do is put a bit more flux on and we'll sort the pins that are bridging. Now we'll use the solder drag method. I wish I could take this antenna connector off. It's doing my nutting. You better not make me take you off. You better not make me take you off. You're fine. Come on, you two. Just change the tip. It'll be easier with the chisel to drag it down. Here we go. Already done, look. Okay. Let's get them all cleaned up. Make sure that there's no bridging. Bit of heat. Yeah, that looks fine. Okay, we'll try that again now. Very strange. You never know. You do get odd things happen at times like this. So let's just go back to battery plus. Go on to the negative. So what are you guys doing on a Friday night? I got 100 other things I should be doing, but I'm avoiding doing them by doing this. Where are you? Oh, there you are. Okay. Let's fire him up. Antenna was over there. Okay, let's check it with the multimeter again. I find it hard to believe that that regulator worked and then blew. Unless I killed... I tell you, the only other thing that might have happened is I killed it with the iron with heat. It might be one of these bloody super sensitive ones. DC volts. Yeah, no, we've not got it. We're getting 5 volts in, which is fine. She's gone. The only thing I can think of on this is I've burnt it with heat. You know when we did the iron swap, whether we've burnt a, it's just burnt a wire inside the IC off. That's the only thing I can think of at this point we may have done. Interesting. Very, very interesting. So, to prove that, we'll swap it again. Because there's no short on the output. So there's no reason for the regulator to just pop. So the only thing we could have done is we've killed it with heat. That's the only thing I've got in my head. It's the only possible explanation I have for it. So let's get it off. It's very possible. A little bit intrigued on that. Okay, I'm not going to put too much flux on this one. This is a good board. I don't want to damage too much this one. So I want to just lift the IC only. Good. I'm going to rotate the board rather than the chip. Okay, let's get the position right. Sorry if I'm not talking a minute, I'm just... Oh, 1 second. It's my fault, I'm not comfortable. I'm not in the right position. Let me get in the right position. Whenever you're struggling, whenever you're forcing yourself, you're just not going to get things the way you want them. There we go. It's better. The only thing that really frustrates me on this station, this is the Autel station. I'm just going to go back on with a bit of heat. Hold it, hold it, hold it. You got to keep it still. Off quickly. Okay, we'll let that cool. Sorry, coming back over to the chat a sec, guys, while we let that cool down a moment. Wow, we've got 85 of you. Cleaning my desk, it's been a while. Yeah, I need to do that, mate. I really do need to clean my desk. It's been crazy. The soldering station I'm using is the Autel ST862D. So variable temperature, variable air. Very good bit of kit. Apart from it has a stupid start button on the handle. So when I lift it out, so I'll lift it out now, it doesn't start. And it's got this really countersunk start button. So I've had to put a bit of glue on it. I don't know if you can see it. So I'm now able to pick it up, put my hand there and tap it, and it kicks in. But if you hit it by accident, it turns it back off. The quick stations automatically start when you lift it out. I cannot get this one to do that. It's really frustrating. I'm almost at the stage ST862. Okay, so let's just give that a bit of a clean now. That board is still very hot. We're going to wait for this board to cool now before doing anything. I'm just going to solder the wires on. So I'm just going to solder the power back on, but it's very hot still. So I'm going to let it completely chill before we power him back up. Could have overheated the regulator or something like that. It might have been hot when I fired it up. There's always that possibility. There we go. It's always good to have one of these on the bench, actually. If you're going to have something like this, which is a PC fan. So if I take him and put him on my supply, I can then just put it in between. I've got an XT60 on it, so I've put an XT60 pass-through on it. And my bench supply has an XT60 as well. So the nice thing is it's always wired, ready to be used. Let's disconnect the positives and the negs, power the power supply on, and then just place the fan over the top for a couple of minutes and just let that chill the board down. I picked up the 87622 in one recently. Really good bit of kit. Yeah, a good ear station makes all the difference. It really does. The difference of performance you get from a good ear station just makes life a lot easier. It really does. I am out of focus. Back now. It's my focus aid. I will check shortly. Yeah, I'll check over there shortly. We're just going to let that one cool down. So this coil thing is quite interesting on these VTXs. Right, nothing you've seen here today is because HDZero boards aren't made very well. All of these is simply because of how delicate stuff is. It just is a reality that this stuff is quite delicate. And it's not as simple as just old analog. It really isn't. Okay. Temperature feels good on that now. Can't beat a good speed bench fan. Okay. So let's get some power in place and see what happens. We're not going to worry a second without the antenna. It's not 1 second's not going to make a difference. Going to just get our multimeters, probes, and have a look what's going on. The problem is, what I don't know is that the only regulator for that, and is there an enable on it as well? There could be an enable, you see. Ground. So we want that. We want. Ooh, 1.8 volt. Okay, let's test the test pad, shall we? Oh, that's worrying. It's a strange amount of voltage there. 2.1. Something really odd is going on here. That's not good. At all. The problem is we don't know what other damage has been done further down the line, and this is the problem. We've had a voltage, you know, the likelihood is we've had the coil bin out, we've had a voltage strike. What we don't know is what else has happened. I'm just going to connect everything back up. Power back up. She's taking a bit of current. So, yeah, those voltages are off. Big style. Hmm. 2.37 is a strange number. We're getting 5.3 in. That's perfect. I'm starting to wonder if we've got something going on with some of the sundry components down here. Let's just pop that off. We've had a bit of heat into that area. There's nothing here. So that's coils. The coils are fine. I'm a little intrigued about this lot under here. Something just stuck to the back of the board. Interesting point. Oh, he's all clean. I got nothing in the wrong place. All looks fine. One second, guys. I don't know if this is going to add a buzz to the stream or not, but I'm going to have to plug it, the microphone into charge. It's gone flat. Is there any buzz with... Sorry. Is there any buzz with that? Any buzz on the audio? It's plugged into mains as well. I can put it on a battery bank. Slight fan noise, but nothing bad. Okay, that's fine. Perfect. Thank you. Okay, so... Ow. I think that's my last chance on this. If this doesn't work, I'm going to give up. Something's let go. Possibly something's let go somewhere. it is the way it goes sometimes, unfortunately. I'm just going to let that cool a moment. And what I'm going to do is, interestingly, pop that other regulator out. It's my finger. Good job. It's not super bad. I'm just going to look at this one a minute. This is the one I poached that IC off. We'll possibly put it back on there if it doesn't. Just going to let that cool. Clean the top a bit. Everything else on it looks good, you know. There's no... Ow, my finger. It's only a slow fan, so it's not terrible. Everything else looks good. The only thing we could... Oh, bloody hell. Keep feeling the fan. It's not hard enough to hurt. It's just the shock of the fan hitting. Just waiting for that to chill off. Then we'll see. Okay. So, let's get ourselves soldered back on, because we've, as always, unsoldered the wires. Well, out of, I think we fixed 4 out of 6 or something like that so far today on these. So I'm just going to do this off camera because it keeps wanting to move. There we go. Make sure that's right. Yes, that'll do. Yes, that'll be fine. We're going to connect power. Let's do some voltage checks. So again, what we're looking for up here is here 3.3. Now we're back down to 0.5 again, guys. Something going on around that regulator. Definitely something going on. We're getting 5 volt in. We're not getting them out. It's hard to know at this point how far you go, I'll be honest. Something I could do, actually, and here's an interesting thought. I'll do 2 more things. So I'm going to lift one of the coils, and then we'll put that one back and lift the other coil. And the reason is, if there's something dragging the regulator down on one of the 2 outputs, then lifting the coil on one side should tell us which one it is. So what we'll do is we'll lift the coil on one side. We'll completely pick a random one. It doesn't matter which. We'll lift it. We'll lift this one. There we go. So we'll simply lift him on one side. Yeah, coins are always good to have. Let's just soldering ourselves back. Oh. Get the other wire back on, one moment. So what I've done now is lifted the coil on one side, and that will just allow us to just see which one it is. Let's get the fan back up and running and let it cool. A second. Yeah, that's the look. You can go forever with this. There's a point on these where a board that costs 50 quid. I'm not going to spend much more time on it. If we can do quick and easy, simple repairs, it'll be nice to figure out which side it is. I've learned a lot today on these already. No, that's the actual fan blades you're seeing. It's not interference. It's just the fan. If I stop the blade, see, there it is. It's the actual fan. Okay. So if we just check again what we're getting. So where the coil should be. Ah, that's interesting. We're getting 1.3 volt. What are we getting on this side? 0.56. That's not right. What are we getting on this side of that coil? Yeah, that's low. That's very low. What's interesting is, I think that side's all... Oh, no, it isn't. It's up to 2 volt. Mind, we haven't got the coil there to smooth it out. 2.4, 2.5. Should be 3.3, though. Still not right. Interesting. Interesting indeed. I'm still tempted to think one of these components is gone. Let's just have a look, shall we? Right, let's go to resistance mode. What are we getting on these resistors? Let's just check these couple by here. These really little ones. Let's just have a look. I'm just wondering if one of these has died with the heat, because they're such small components. Let's just have a quick look. We've got 2 resistors here, right? So let's just have a look at what we're getting on these. 32k on that. 10k on that. Right, that's 10k. I'm betting that's fine. If we check another one that's the same. Is this one got crap all over it? It has, but that should be 10k then. If I can get the bloody thing to read. Have I got any of these without all the crap over them? Oh, they all got it. Oh, what about this one? Yes. What about this one? Oh, that one's better. What's this one got? Let's just have a look. $10k. 50k. 10k and 50. And what we getting on these two? 40. It's quite a lot, isn't it? It's 10k difference. We're getting 10k. 10k on you. Make sure that capacitor isn't shorted to ground. Actually, what's the bloody hell's going on there? Hold on a minute. Let me just check that on this one. What are we getting across you? That's interesting. Although that could just be what I'm getting across the IC. Intriguing. Less than I'd like. I'll be honest. Let's check these two here a minute. Oh, he's come off. Bit easy. Hello. Stay there, you. We've got a resistor come off. I'm just going to do this a sec, guys. 1 second. I'm going to have to tag him back on. Yeah, that's fine. Right, I got a resistor that's come loose. Let me just, I say come loose, I pushed it off. Let me just tag it back on with the iron very quickly, just to show you. That one there. That little one down there, look at him. He just fell off as I gave it a touch. Get back, you. Sorry, that's my bad tweezers. That's why I'm struggling. Where's the other pair? I got one pair with a really bad nozzle and another pair with a perfectly good nozzle. Nozzle? End? Whatever we want to call it. Grip? Tip? Where's the other one's gone? Where are they vanished to? Something I'm going to do is wrap tweezers, right, in fluorescent tape. So I can see the damn things. Use these aren't bent, but stay there. Behave. Come on. Behave. Stuff this small is where I start to have trouble. That's not good enough. I need the bent ones. Where are they? 1 second, guys. Let me just find my second pair of bent ones, which should be here. They've completely vanished. Oh, they're over here. That's why I can't see them. Okay, let me just get this sorted. You gotta take off. I'm gonna have to take it off. So, 1 second. Swap the tip. Tin the pads. Put him back. Okay, let's see if this is going to play ball. Two secs, guys. I'm just fighting this damn thing. Needs a touch of solder, on it, and we'll be all right. Be back on. I don't want to do it with the. There, got him. Right. Sorry about that. Sorry about that. Okay, so. Right. We're going to do one last thing. One last hurrah. I'm happy with that resistor, but I'm not happy with him. So we're going to swap him and swap the cab. That's the last bit of logic I've got, and if that don't work, I give up on this one today. Okay. Now, we may do these by hand if I'm... no, we won't. We'll do them by ear. We need to get them off this board here. So what we're going to do is go one at a time. So we're going to go for the resistor first. We'll take him. Ow. Okay. My tweezers are a little bit big for this. We're going to go around there and see if we can get an action on them. Then we'll hop over, grab the cap. Bit too much solder on that. Yeah, that's there. It's not the tidiest, but it's there. And then we'll come back and grab the cap. I'm wondering whether to do the cap with the iron, but it's not normally that easy. No, okay, let's do the cap with it. Sometimes easier to tag them in place with the iron and then... Right, what we'll then do is flux them and float it in place with a bit of it. Sorted. Okay. Okay, so we'll just let that cool a minute. We've just replaced those two because I had some suspicions about them. We'll pop the coil back now as well. It's a good time to do that. I don't feel there's anything wrong with the coil or that side of the circuit at least. So It's a good chance for us to get that back on now. So let's just tidy up the pads for where the coil went. There we go. Him and him. There we go. And then we'll get the big coil back. Bit easier with a larger component like this. Give him a wiggle. He probably wants a touch more solder, to be honest, but he'll be fine. My microscope. So the microscope I've got is the Eakins. I think I paid about $400 for this in the UK, getting it over from China. It's very good, but I am disappointed in the camera port. What I see is a lot better than what you guys see, if I'm honest. What you guys are seeing is a very, very small portion of the view I have. Just top up my isopropyl. The view is just not as good through the camera port, or the tri-port, it's known as the trinocular. It's a trinocular microscope. The only thing I'm wondering is whether we've got some heat in somewhere we shouldn't have. If he doesn't work this time, I will be calling this one a night. But it will then become a parts board. There we go. Good. Okay, let's connect the solder the wires back on while we let them cool. We want our positive and we want our negative. When we find the black one, where is he? He's over here. Be fine. Just going to disconnect the positive a minute, put the fan back on and just let him chill for a couple of moments. The actual trick to the fan is to prop it up a little bit off the table. If you can prop it up a bit, it gets more airflow through. Okay, let's catch up on the chat. Hey Ian, did you notice the Cadex HD cameras are dropping in price? Is that a signal of the new system coming in? I hadn't noticed that. That's interesting. We'll talk about that Sunday. My station is the 862D. Is my station. So mine is the Aten 862D. That's my one. So the light is terrible in here. When it's like this, the light is shocking. This is why I have a certain lighting in this room, because when it's like this, it's just not great at all. I'll just let him chill down. If I have another 70 VTX board down mode, yeah, it's definitely something off for that voltage regulation. Okay, should we power him up and have a look what it does? Oh, get off. Get off. Makes me jump every time. Behave. Right. Oh, we got blue flashy lights, gents. Hello. Hello. Should we have a poke around very quickly before it overheats? Shit, wrong mode. Three volt. Bit lower than I'd like. 3.1. 1.1. 1.4. Let's get an antenna on it, shall we? And a camera. Could be getting excited now. Okay, we're going to get the fan over it as well because it does tend to overheat. So we'll turn it on first. Oh, we're getting a good amount of current. Oh, ho, half an amp. Hello. What's that little LED doing there, look? Right. Let's put that over the top of it, shall we? We need battery, we need power. I've flattened 2 batteries on these bloody goggles already tonight. Right, one moment. Let me just check which of these is dead, which of these isn't. These aren't my bench packs neither. That one's alright. Taking that down a bit lower than I should have. That one's 3.7. That'll do for a quick test. 3.7. What do we think, gents? Ladies and gentlemen, we have video! So, it was some of the components on the side. Very, very good. Absolute brillianto. Cool. So, again, it is worth pursuing these things, but there's a point where you have to decide, am I going to continue or not? But this is all a learning curve, and this is all, where do we start? Where do we go? Where do we continue to push? So what we had was something off with some of the components down there. So what we ended up having to do was replace them and resolder them. The thing to understand as well with some of these low cost components you have on these, heat will damage them. Take it easy, Lewis. Thank you very much. Yeah, she's still alive, guys. So I'm going to power it down. That's good. But the thing to understand is, especially with some of these, you know, the low cost components on you, they will damage easily with heat. They will get damaged. So you do have to be careful. You do have to be aware that you might need to go in and start moving stuff around. And you'll often see it with Lewis Rossman, where he will like cover an area of the board in flux and just reflow the whole lot. And that is why he does that, because you do get problems like that. It is very possible. So that is a thing. So if we think about this VTX, this one here has had a blown coil. I don't know if that regulator was bad, that original regulator. It's possible there was absolutely nothing wrong with it, and it was the components around it, not the regulator. It's hard to be sure on that one. But what we do know was we replaced the coil, first of all, which had burned out. So that was the first issue. We then moved on to checking the 5-volt rails were good, but we didn't have power on the 3.3 or the 1.2 and 1.8 rails. So we then took a punt and found out, and that's a learning curve, that that's a buck regulator. We've got the coils either side. So if we if I just walk through as we do this, if we zoom out a little bit, we learned And the learning today is, you know, we started with that coil here, which was burnt out. We then moved over to the buck regulator, and we now know that this is a buck which feeds 1.8 that way, I think 1.4 that way, 0.8 that way. I need to double check. And then you've got the sundry components around it as well. We've got these up here. So this is all power regulation, and that's the thing we've come to learn from this, really, more than anything. But again, it's another successful repair. I'm going to just desolder the wiring on this one. 1, 2. I need to mark this one up because I know this one, which one this one was. So let me just come over to the top here and turn that off. We've also bricked my goggles tonight live. So I need to just mark this board up because these aren't mine. They've been sent to me and they're going to be going back. Bit of tape. If you guys have got any questions, I'm happy to answer them. We'll have 10-15 minutes before I wrap this stream up. We've been going a while. 70 of you. Fantastic. Hello, if you're new here. I normally stream on a Sunday night, but I thought I'd just do a stream doing this tonight. I'm just labeling these up. So I know which one's which. Okay. So D1, D2, D3. So that's those 3 done. So before I come on here, I'd already fixed 2 of those with coil issues. Now, something I have done on one of them, I say fixed. One of them, I've actually replaced, I've just bridged the coil. I've just bridged the coil pass. Let me show you it. Which one is it? So I haven't decided if that's a permanent solution or not yet. Is it that one? Oh yeah, it's that one. So that one there. So let me just show you. So this one also has a coil gone, but I've run out of coils. I live stream on a Sunday, 10 PM UK. So I start half an hour ago from now. Top of the hour from now, half an hour ago from now, you know, top of whatever hour it is, wherever you are. If we just look at this one, this is another one I did earlier. Now this had another burnt out coil. Now what I've done on this one temporarily is I've bridged the coil because the coil is on the power input. Personally, I don't see a reason we can't bridge the coil. I am going to do some investigation on this, but that's what I did on that one a minute. Just bridge the coil to allow the voltage to continue through. As part of the repair on that one. So whilst we haven't replaced the coil, we have done a repair on that one. So we've done 2 with a coil and a total other repair, and then 1 with a coil bypassed. So that was those 3. Of these 3, we've got 2 UFL repairs. And then we've got 1 now with a broken MIPI chip. Oh no, yeah, 2 UFL repairs. Let me just check. So that's the one with the broken IC. For those who haven't seen yet, if you weren't here at the start, this one has a cracked IC, which is there. If you see there, the crack on the IC, you can see it on the corner there. So that one needs a replacement, which is, I don't want to jump into doing that. I get the impression they've had quite a hard life. He does a lot of bashing. Some of them are his, some of his mates. So the story was he had some broken ones, his friend had some broken ones. So they said they'll club them together, send them to me, and we'll try and put parts together for whatever works or doesn't work. The irony is, so far, I've repaired all of the boards of one And we've got, let me just check what we've got here, just so I don't get myself confused. We've got this one, which has no damage, but we've used it as a parts board. But it just didn't work. We just had no way of getting it working at all. So I've partsed that board out. We've got this one. Which one's this one? Let me just look. Okay, so that's the one with the broken chip. So that's yet to be repaired. And then we've got 2 UFL repairs. Yes, 2 UFL repairs. Okay, so today I've done 5. We have 5 VTXs repaired and working. And there's 2 that are not. That one, I know what's wrong with it. The next probable goal is whether I consider doing a chip swap from that board to that board. I am not 100% confident on that process because I don't have a reballing stencil for this one. So when I lift it, I'm going to have to lift it and just place it back again and hope there's enough solder there to do it. But it's a risk. That broken MIPI chip is a thing. So yeah, it's quite a successful day. I enjoy making these content. That's the scary one, lol. Yeah, I've successfully done 1 and not successfully done 2. But the 2 I've not successfully done, it was just more complicated than it. There was other issues as well. So, but if you take into account, so there were 3, how many boards were there? Let me just got a lot. I have a spreadsheet with the details on. So there was 4, 5, 6, 7 boards. So 7 boards, 5 fixed. So far. We may be able to make that a 6. We may be able to make that a 6. I've got to think about that one a bit more. I'm not rushing into doing the IC swap. That's a bit more complicated and requires a bit more time and effort, and it's not something I'm going to do on stream, put it that way. It's probably not one I'm going to do recording. It's one I'm going to do off air, probably. So out of the garbage into the sky. Yeah, I'm going to try and get some more ESC videos and stuff done as well. Really, it was just a bit of downtime for me, this as well. This is the kind of thing I enjoy doing. So it's just a bit of downtime. Interesting that all 3 boards had the same coil problem. That is not something I've seen before. That's a new one on me. That's a new one on me. Right, guys, I am going to call it quits. I want to thank you all for spending some time with me for this loose one. Solution to my goggles battery problem in the Discord chat. I need a power supply for it is what I need. Let's have a look at the Discord chat. 2 seconds. The UFL ripped off. Tuna Taxi FPV, if you're still here, I'll come back to you. What we got here? No, that's not that. Discord. Let me get onto the group. Where are we? That's a live chat. Hello. What's this? Battery alarm in your goggles. I printed this. Yes. I've got one of them in a drawer. Yeah, I'll come back to you. Give me a bit of time and I'll come back to you, my friend. Definitely interested. I'm just trying to space things out because I can't. I literally could have 100 of these boards here right now. I've got to be careful to just keep on top of the postage and everything like that. So I'll come back to you. Definitely we'll sort something out, mate. Yeah, to be honest, I need a bench power supply. I've got a bench power supply, but the bench power supply is powering other stuff. I want to get... I need to just get some bench power supplies for doing stuff here. Simple as that. Right, guys, stay safe. Look after yourself. I'm going to kill this one. I will speak to you very, very soon. And a massive thank you for the super chat. And before you go, give us a like. Stay safe, guys.